Hello, everyone. This is the part 1 of our live coding project on extracting nighttime light statistics using Google Earth Engine. You can find the link to add this code repository to your code editor in the video description. Once you click on this link, you will see this repository called end-to-end projects in your readers tab. From there, you can go and find this folder for nighttime light statistics, which contain all the code that I'm showing you. The way the code is set up is that we'll be starting with the script marked A. I'll code live and I'll build the full script that is already contained in the script B. So you can look at my screen, I'll explain each step. And once I'm done, you'll already have the code for this in script B. And you can try to replicate and adapt it for your particular needs. So let's get started. So we are starting with the script 01A. As I explained in the previous video, we'll be using these 3 datasets for this project. We'll be using the admin boundaries from GeoBoundaries. We'll be using the VERS nighttime lights composites, which are annual composites. We'll be using the MODIS annual land cover products as well. First step is to apply some filters. So let's select one admin region of the world. To do this first, I will just load the full admin1 layer to my map. So I'll just say map.add layer admin1. This will load all the polygons for admin1 regions from this particular data set. You can zoom in to any region that you're interested in. Let's say for this particular project, I want to compute the stats for California. I want to know what is the name of this admin region and what's the property for that in the dataset. So I'll use the inspector tab and click on this. As I click on this, you'll see the objects here. I'll expand this feature. This one has 7 properties. And you can see that these are the different properties associated with this polygon. And here we have the shape name, which is California. So if I just want to select California from this, I can just apply the filter which says, give me all the polygons where shape name is equal to California. So let's say I will just use a variable called region and we'll just define it as California. So we'll add a filter. We'll just say admin1 filtered. Say admin1 dot filter, and we'll apply a filter filter EQ. And we already know the name of the property, which is the shape name. And we'll say shape name equal to California, or the region. We already have the name here. Okay. And this is our admin1 filter. Let's see if we got the correct one. And I'm just going to comment this one out. We don't need that full layer anymore. Okay, so this displays just the California. So that's great. What we loaded is still a feature collection with just one feature. A feature has a geometry and some properties. For most operation, we'll just need the geometry. So let's extract the geometry of this collection. We can just say admin1 filtered dot geometry. This is extract the union of geometries of all the features that are there, which is just one feature in our case, and it'll just give us a geometry, a polygon for that region. So we can just display the geometry here. And let's just display it in a different color. We'll say display it in gray color, and we'll name the layer as geometry. Okay. So we applied filter to our GeoBoundaries dataset, and we'll found geometry for the admin1 region that we are interested in. Next, we want to work with the nighttime lights dataset. So let me just print this NTL collection, which is the collection that we have chosen for our project. You can see this is an image collection having 9 images inside. Each image is from a different year, 2013 to 2021. Let's say we want to work with image of one of the years. So I'll say, want to get load the image for year 2020. We'll apply a date filter. We typically need a start and end date. So we'll just create this date for the given year. So start date will be the 1st January of that year, and then end date will be start date advance 1 year. Right? You could also hard code this, but I like this way because this will help us when we are doing this programmatically. So get used to defining your start and end dates like this, using the e-date from YMD function to create the start dates, and then advance it by whatever period is relevant for your analysis. Now let's filter this collection. So we'll just say NTL filtered. We'll take our NTL collection and apply a filter. We'll want a date filter. So we'll say E filter date, and we'll just say start date and end date. Right. This will give us the images matching this filter. Let's see what we get. And by the way, if you want to just run the code without leaving your keyboard, Control Enter is the shortcut, and this is super helpful. Instead of reaching out for the button, you can just do Control Enter and run that. So you can see now we have filtered down a collection from 9 images to this one image, right? And you can see this image has 8 bands. So this is an annual composite that means it is created from all the images that were captured during the course of the year. And what value do you get in the image? That depends on the band. So if you select the maximum, that means each pixel has the maximum value observed during the year. So the maximum radiance observed during the year. There's also minimum, median, and so on. Let's do the average. So average is the average radiance throughout the year. This is what we want for the annual composite. So we'll select only the band, which is the average. So I'll just define the variable called band, and just select that band. Doing coding like this is helpful so that later you just say, I want to change my analysis to use the maximum value. You can just change the variable and your whole analysis will use that instead of hard coding. So you can see now I have an image collection with one image having one band, right? So we just selected that band. If you want to load this image or do something with it, we have to create an image. We still have an image collection. So if you want to just get the image, so our image collection has only one image, and we can use the helper function called first to extract that first image out of the collection. So we'll say NTL filter dot first. This is a function that will give you the first image that is inside of a collection. So you can see we had an image collection, and now we have an image. So we have one image with one band. So we got our image for year 2020. Let's visualize the image. So to add this to the map, we'll just say map.addLayer NTL image. We need to compute some visualization parameters, but right now, let's just keep it, there's a default parameters and see what we get. This image has one band, so you'll see the resulting map will be in grayscale with the lower values as black, the brighter values as white. And you can see this gives you a fair idea of where the urban areas are. Let's create a little better visualization. So we'll define some viz params. We'll define some min and max values to be used for our visualization. Let's just use 0 and 50 for now. Again, this choice of min-max values will depend on the data set and the region you're trying to visualize. You can play around with this and see which values make sense for the region that you're trying to visualize. And then we'll also need some palette. So we'll need some color palette. We're going to use this palette. I usually find my color palette from the website Color Brewer. You can go there and find the color palette you like, and then export the CSS JavaScript colors that can be used in Earth Engine. Okay. So I'm going to replace this. Now the same image band will be displayed in different colors, ranging from this color to this color. This color will be mapped to 0. This color will be mapped to 50. Right. So we can see we have this image. Let's just clip it to the geometry. So we only see the data for San Francisco, sorry, for California. Right, so we now have the nighttime lights image for 2020 for California. The third data set that we have is the land cover data set. So we have the Modis land cover data sets. Let's just print it. So the data set we have is in this variable Modis land cover. Just going to print this. This also is an image collection. You can see it has got images for each of the year from 2001 all the way till 2022. Each image itself contains bands for different types of land cover classification. Let's look at this data set. If I just search for this ID here, you'll see that it pulls up the dataset description page. I'm going to go here. And you can see there are different bands here. And each band contains the land cover classification for a particular classification scheme. We'll be using the LC type 1, which is the IGBP classification, right? And if you use that, then each pixel value that you get will correspond to each of this land cover. So to pop it open and keep it open, we'll come back to this in a second. So we'll define our classification. We'll say I want the LC type 1. Again, we'll put this in a variable. So if you want to change it at any point, we can just change that and our whole analysis will use that. Let's apply a filter. We'll just say, we'll take our modus land cover data, apply a date filter. So we'll filter it for the start and end date that we have chosen. And we'll select the classification band. So we'll just select the band that we are interested in. Let's print this. Okay, so we have this image collection with just one image having this one band of the land cover classification. Let's extract that. So we'll create a variable and we'll say land cover filtered dot first. And this is a general strategy in Earth Engine. You filter it down until you have only one thing left, and then you can call dot first to extract that and create an image out of this. If you have multiple images, you typically have to create a composite. So you can then call median, mean, or any other way to create an image out of a collection. So we have a land cover image. Let's create the visualization. I'm going to copy paste some visualization parameters for the IGBP classification. The pixel values range from 1 to 17. There are 17 classes, and these are the colors corresponding to each of those classes. And let's just add it to the map. And we'll clip it and add it to the map. So we have done filtering on all our 3 data sets. We have the geometry for the admin region, we have the nighttime lights, and now we have the modus land cover. You can see each color represents a different type of land cover. The gray area here is the urban region. So you can see this corresponds to the urban region, and then the green stuff is the agriculture. And now we want to, in the next step, we'll learn how to compute the statistics of nighttime lights within this region. We'll also then learn how to compute stats by each of the land cover that we choose. So we are done with this. The finished script is in script 1B. That script also has some additional comments, so you can learn a little bit more about the code. I'll see you in the next video where we'll start working on script 2A.